Hey, everybody, we're back again. And now take a look at where we're headed. We're going to see Al Collins and Ultimation Tools. And this is an interesting story. He actually came to the show for the first time last year, and he sold one product, a sander. And it's a hand-controlled, hand-driven, you crank, and you'll see the video in a second, sander. And as I was really taking a close look at it when he was preparing to come on the show, I just couldn't believe, when you take the time to look at this stuff, it's like, really? This is incredibly cool. And I need one. So, and I actually said to him, where the heck were you last year when I scratch built, or like a year, and it's right before the show, before he came up, where the heck were you when I was scratch building 50 buildings for the Northampton diorama, because that's what I needed it for. And honestly, with the amount of building I'm doing now that I've got all this free time, other than this, for my Berlin Banger in Maine, wait till you see this. I said, I have to have one of these. So I got really crazy about it, and they're really cool. And then after I watch that, and you'll see, you know what? I'll leave it at that. Let's go watch that first video, and I'll be back, and then I'll tell you what happened afterwards. So hit that video.
Hi, I'm Gerry Cornwell from Mt. Albert Scale Lumber, and I'd like to introduce you to an exciting new tool in the workshop. The most impressive structures on a model railroad are timber structures like trestles, trusses, wharfs, and snow sheds. They're also the most challenging to build. The challenge is to build a straight and plumb structure, like this one. Ultimation, a new tool company, started by the founder of Mt. Albert Scale Lumber, has combined the latest in machine tools and industrial lasers with model building skills to produce the Ultimation Sander. The Ultimation Sander makes it possible to get great results like this, shown on a Hunterline snow shed kit. This kit requires over 700 precise angle cuts. You get tight, precise square joints every time. It features repeatable accuracy within 1/2 of a degree. The rubber disc edge allows fingertip control. It can sand to 1/1000th of an inch accuracy. And a double ball bearing stainless steel hand crank guarantees friction-free operation. It uses self-adhesive, easy-to-change 5-inch sanding discs with different grits available. The Ultimation Sander and your creativity, a great modeling team. Contact Ultimation and order yours today.
So now I look at that sander and I'm thinking, well, wait a minute now. I need to repeat parts. And then the son of a gun comes back with another video of how you could add this attachment, and for lack of, I'm not using the right term, and forgive me, Al, but it allows you to attach this repeater. So let's take a bit of another look at this, guys. And by the way, Ultimation Tools, if you go to ultimation.ca, because Al is from Canada, hence the .ca. You'll be able to check out a little bit more. Watch these videos at your leisure again if you'd like. But check out this next video. It's about 8 minutes long, but it is so worth watching because it really shows you how this thing can do precise. And I'm talking precise down to about I guess, I forget what he says, either 1 millimeter or 1/2 millimeter, guys. So this thing is so darn precise. It's what every scratch builder needs, I'm telling you. And it's something I gotta have. Al, are you listening? I have to have it. So let's play that second video. Let's go to it.
If you're ever building anything, it's a good idea, in my opinion anyway, to do all the parallel stuff first. Because then whatever you're filling in between doesn't change. It's constant.
Right, okay.
So what we want to do is, I'll take these out of the way. I didn't stain these so they maybe show up better. And I wrote master on here, and Gerry pointed that out. He said, Al, make a note on your pieces because you keep losing them.
Right.
So the biggest job is to make the first one. So we're going to make a master, which is a perfect fit.
Okay, and I'm just going to move these finished ones out of the way so that we can see the new one you're making.
All right. So first of all, we're going to go back to junior high days with our plastic protractor, and this becomes invaluable. So as I said, the tedious part of this whole process is making the first one, the master. So we'll go on here, we'll get an approximate angle, 35 degrees. So now we go to our protractor on here.
Right.
Sorry. And we set this at 35 degrees. That's a starting point, 35 degrees.
Okay.
Set that over there for now. So I've set 35 degrees on this one, and the reason that I'm bouncing around is that unless you clamp this down or bolt it down, it's going to be bouncing all over.
But it also has, you've got holes at the bottom. You can literally, bolt this to the workbench.
Or a lot of people bolt it to a piece of plywood that's heavy enough. But if you don't, you have to have this secure before you start into this. So what we're going to do is we're now going to set the protractor, as I showed you on there, at, let's go to 35 degrees to start with.
Okay.
Then we will, I've taken some pieces of wood to save time and approximate it. I used a chopper and I just cut an angle on it, whatever. So now I'm going to put this in here. I'm not going to use any of the mechanism on this other than I'm going to use it as a push stick.
Okay.
So I got that piece of wood in there. Now I'm going to crank this. I can back it up to get rid of the majority of that fuzz.
Okay.
As you can see now, one of my other favorite tools is a scalpel. Not that I'm a surgeon. You always, inherently with a disc sander, you'll get a little bit of fuzz. It's nice to just wave the scalpel over. You don't have to lean on it.
Okay.
So now we can go back to our drawing. We can lay that on there. And you can see it's open a little on the heel of that angle.
Right.
It's tight on the, so that means we can go back to our sander now. And we want to take a bit off the toe.
Right.
So we're going to go up to 37 degrees.
Okay.
Just a few cranks. Now we're going to put that on.
Oh yeah, that's.
And lo and behold.
Yeah, perfect.
Perfect.
Flat. Oh, that's lovely.
So we know that's 37 degrees. So we're going to do ourselves a favor.
And we then know that this is going to be 37 degrees too because of the parallel.
Because they're parallel.
Right.
But we're also going to do ourselves a favor.
And write it on there,
and
right.
Just in case.
Good idea.
So now we know that that's the angle we want. The next thing we need to do is come up with a length. We do our 37, I've taken another one. I've taken the liberty to make another one. We've done our 37 degrees. I've cut these off fairly tight in length, because if it's out here, you're going to be sanding for half an hour.
Right.
So you can just lay this on your drawing, mark it, cut it on the chopper, and again, make sure that you get the angles going the right way.
Right.
So now again, you can use this part as for the initial cut. You can use that part just as a push stick.
Right.
Way too long. Now to save time.
So you're going to keep going back until you get it to the right length.
To save time. Okay, here's one, if you can see the line, it's close.
Yeah.
So I'm suggesting that I've got to take about a 1/16 of an inch off. This is where the repeater starts to come into its own. We bring this up now so that this part, the body off it,
into the length.
We lock that into length. We want to ensure that there's a few threads shown on the back end of this thimble here.
Okay.
Otherwise, there's potential of running out of travel.
Okay.
Now we know that we want to take about a 1/16 of an inch. So if we can see the gap here between the thimble and the back, we just open that up. There's that 1/16 of an inch that we want to take off.
Wow, okay.
All right. Now, we just sand until that hits the stop.
Oh, I see. It closed, so this gap closed up here.
Yeah, the spring, if it's a little too slow for you, you can help it just with your thumb. Once it stops sanding or hits the stop,
Wow.
we can go back.
Wow, this is
Almost.
This is like so precise. This is
Almost.
astounding.
We still got, you can see in the line, we still got a tiny little bit. So now you have two options. This is the, I've been called too fussy. So now you get two options. You can crank it for that last little bit, or you can simply turn,
Oh yeah, okay.
and turn this with the rubber edge. And we probably only took a few thousandths of an inch off. All right, so that's one way of doing it. The other way is the same idea, except this thimble is gradiated in thousandths of an inch.
Okay.
So something tells me that I want to take 5 thousandths of an inch off that. So there's 20, there's up to, there's about a 5 thousandth of an inch gap in there.
Right.
Now we're being extremely pernickety just to sort of demonstrate. We now can put that piece in.
That is incredible.
So that becomes our master.
And obviously, if I'm doing 30 of these, I'm going to do these angles all 30 first before I start working on the other end.
Yeah.
Okay, got it.
So, and the way to get around that is once you've established the angle and the approximate length that you wanted, we worked on a length here, you can set that length up again. We'll go back to our 30. And this is where it's so important to keep that 37 degrees, because now you can go wherever, do whatever, and then if you have to come back and make some more, you can come back to 37 degrees. So here's where, again, we can use the repeater. So there's our blank length with one angle on it. Mm-hmm. So now, if we needed 500 pieces, we could make 500 pieces the same blank length with the first angle on it. And we can make all of those that we're going to work with. Then we can go to the other end, as we talked about before. And then we just go and put it in. And then we can go ahead and take those blanks and put the angles on both ends and get them exactly the right length.
That's great.